Yeah, hi everyone. So I'm gonna explain AutoGluon. So this is an amazing open source AutoML framework developed by Amazon, designed to automate machine learning tasks with minimal human intervention. So this is a powerful tool which will make data science and data scientist life very easy. So what are the key features of this? First is it is very easy to use. So with very little or even no code, we can just with single line of code we can train a model. It has automatic hyper parameter tuning, so it automatically tunes the best parameters and gives the best model on basis of metrics we provide, and even assembles them to improve the performance. Supports a wide range of models. So AutoGluon includes algorithm like gradient boosting and random forest and neural networks. And it also has time and so it is very time and resource efficient. So you can provide you want to train a model within a few, like you can give time duration. You can give I want to train a model within 3 hours, so it will in the 3 hours it will give the best possible model. And also you can give what kind of computing power you have, so you can provide the number of GPUs, TPUs, and CPUs as well. So what it is used for? So it is used basically for tabular data prediction and classification, and image and text prediction, and also there is time series forecasting. So I'm going to start with tabular data set predictions and classification. So in this notebook, I've just attached the introduction, and also I have this tabular quick start guide. In this, we are taking a data set from this knot theory. We have different columns on which we are predicting signature. So this signature has this is the mean, mode, and all kind of metrics on signature. And just like while importing, we are not cleaning the data, we are not doing any pre-processing. We can directly predict, like fitting the model, and predictor will just give us the best. So this will just train a model, and we have this model already. We can evaluate with it is having 95% accuracy, and yeah. So it has different models, and best one is weighted assemble L2. Okay. So next one I have is multi-label prediction. So in this, I have we have this multi-label prediction. So tabular prediction for predicting multi-label column and table creates multiple tabular prediction object which you can use individually. You can access the tabular predictor for a particular label via get predictor and giving the label name. Uh, so here is the entire code for this. So we are fetching the data set, and then fitting the model, and we have this direct like predicting using the data set we provide, and yeah, evaluating the model, and then we can see load. So this all these are inbuilt function in AutoGluon itself. So here it is just taking the data set, and then it is using so we can provide this different labels here, and based on it, it has just trained a model. We can see we can see the trained we can see the prediction of this model, like what is the evaluated score and everything. All right. Next we have is a multi-modal tabular. Here we have taken a pet finder dataset. Uh, on so basically this is also just predicting based on what we have in the dataset itself. We so starting we have just imported the data. We have trained the data here. So this is the training data, and then the adoption speed is what we are going to predict. So this is the target column, and yeah. So this is the entire code. We can there are few tunings that we have done here, and then based on the data we have automatically. So there's not much code which we have to write in AutoGluon by using it. So it has trained a model directly. Next we have is automatic feature engineering. In this we have taken again this is very useful. So it is just selecting features just by giving a few lines of code. So this is a sample data set which we have taken, which has these kind of column names, and based on this, it is predicting. So this is just fitting the entire data set, and yeah, uh, it is predicting, and so this is creating a pipeline where we have selected the we have selected the useful features from the data set. Okay, next we have here is AutoGluon we have used for text and image classifications. So number one we have here is like sentiment analysis on text. We have taken data set in this and it has the positive and negative labels. So very pleasing at its best moment is positive, and then this line is negative. So it is going to predict. So within just few steps we have trained the model here using AutoGluon, and it is giving like 50% accuracy because I think like we'll have to train it more. But due to computing resource, I've just done this, and then we can see like this sentence. It's charming and often affecting journey. It is positive, and then it's very slow, very slow. It's coming out negative. So this is happening in just like a few steps. So this is like very powerful feature of AutoGluon. Next we have is sentence similarity. So here is the data set for it. Airplane is taking off and a plane is taking off and airplane is taking off. It's coming up as like score is 5. So this is the data set, like the similarity between two sentences. And then we have just trained model again, just within like 4 lines of code we have trained the model, and yeah, it's coming out to be these are the metrics like of the model which we have trained, and this is like 4 sentences, and this is a similarity between these which is coming out from our model. Next we have is fine tune model, which is basically it is used so this AutoGluon is a so we have used this multi model. So this is used for multilingual detection. We have here German and English dataset. So this is a dataset from Amazon customer reviews. We have different languages here. So as we can have like many languages in the world, so it can identify and just within few lines of code, it can generate the sentiment of the this review. And again, due to limited computing resource, I had to just train it to 1 per. And this is coming out to be the metrics. For German language, it is coming out as 0.61, and then for English it's 0.56, so 56% here. And so we can just train model with different language here. And yeah, this is for the Japanese language. It's coming out for 52%. Okay, next we have is name entity recognition. So given a sentence, we have to identify like what is the name in the sentence, what is the location. And here we have just given the entity group. So we are using these libraries here, Torch Vision, Torch Audio, Torch, and we have just used this multi-modal, this visualized NER model, which is name entity recognition, and it has identified that Albert Einstein and German are person and location respectively from this sentence. Next, we can load the dataset, and we have the dataset here where we have a sentence, and we have given the label as for actor and like year and that kind of stuff, and it is just identifying here. So in this sentence, it has identified the what are the categories of these words. Okay. Next, we have here is image classification. So in image classification, we have taken this clothes data set, and it is classifying these images directly. Yeah, so it's all happening within just few lines of code, you can see here. Then we have here, next is zero shot classification. So this is like identifying the probability of the so we have given an image, and we have given like what are the probability that this image is a image of husky or golden retrieval. So it is identifying that it is a husky, as it is having the highest probability here. And so it's zero shot is basically just having an image and just identifying without labeling the data. So for this, it has identified that it could be a segue, as it is having like maximum probability here. And then we have different. So also this is like the limitation here, where it has identified this as an iPod because it was written as an iPod here. So this is like a limitation of the model, zero shot classification model. Next we have is auto multi-modal detection using this tiny Coco format dataset. So tiny Coco format dataset. Coco format is basically used for image detection. It is like very popular thing for image identification and object detection. So we have given a data set, and it is like identifying the objects in it using this auto detection. This now we have is AutoGluon used for segmentation. First we have is image segmentation. We have installed this AutoGluon model. Now we have this data set where we have images and given some labels for the images. And what this gonna do is it's gonna take out some segment of the image which is important to us. In this case, it is the disease on the leaves, which is important. So it's gonna highlight those in the image and take it out. Like we are having a mask over here, and we can fine tune it and have better accuracy. Next we have is document classification. The data set we have here is some documents, and then we have a label like which category it belongs to. And based on the text in the documents and the structure it's going to classify the document. And we are having here the model which we have trained here, and the prediction, the accuracy is coming up like this over here. Yep. So next we have is PDF classification. Again, we have taken this AutoGluon and we are having this data set where we have the path of the document and label, which is resume here. So this is like a PDF, a resume PDF. We are training the model to identify if the PDF is resume or not. So we have trained this model. Now in the testing, it is coming up as 62% accuracy, which is good enough. Like, yeah, so it has identified like if the image is resume or not. Yep. Next we have here is semantic analysis using AutoGluon. So first we have image to image semantics. So this is a common task in computer vision with several practical applications such as detecting same or different products. So in this we have a data set. So what it's going to do is using cosine similarity, dot product, and linear distance. It's going to identify how the images are likely to be same or not. So we have this Stanford online product image data set, of which we have these products, and it is identifying if the products are similar or not. So this is the model. We have trained this model, and it's giving this 75% accuracy, which is quite amazing. Next we have here is text to text semantics. So text to text is used to so computing similar to the to if two sentences or paragraphs are similar or not. So identifying the meaning behind the text, the sentences, and giving like if it is similar or not. So what it's gonna do is like we have this data set, and it's gonna identify if first sentence and second sentence, how if they are both like it's both are similar or both are contradicting, or it's like they're not related at all. So based on this data set, we have trained this model, and on the so the predictor is having this 89% accuracy score, evaluation score, which is again which is quite good. Image text semantics. So this is used to identify the cross model retrieval thing. So we want to use for image captioning, text to image synthesis, and multimodal neural machine translation. such kind of things. So this we have here is a data set of caption and image, and it's going to match it. So we are training like this caption is representation of this image. Here is an example, and we have trained this model here. And in the test we have identified like this is the caption and this is the image for that thing. Like this is again one example where several students waiting outside an igloo. This is the image. Next here is image to text semantic matching with AutoMM zero shot. So what it's gonna do is it's gonna convert the image to text, identifying what all things we have in the image, like object detection over here, and it's gonna match with the given text here and identify which is the similarity between it. Again we have some text and some images. We gonna so it is using this model called clip here. This is the image, and so it's gonna extract this plane and car from it, and identify if there is an airplane over a car, and identify airplane and car are similar. So it might just give us similarity rating on that case, and it is giving us the score. So again, due to computing resources, otherwise we could have trained this model very perfectly. Next we have is text semantic search using AutoMM. What it's gonna do is search a sentence in an entire document, and based on cosine similarity, it's gonna identify if there is this text available in the document or not. We have this data set where this is the text and this is the document URL. And so this is document, we have just displayed the sample documents here. And it's gonna give us like the rating of the model which we have trained this model. Here we have trained this model, and yeah, this is it. Now we have multi-modal text tabular notebook where so we have used AutoGluon to identify. So we are predicting a price of a book, but the catch over here is like the text on which we are predicting are not just the text. It also has like numerical and categorical data. So the problem statement here is like text data may be like of a mixed data types, and even if it is like this, we can use AutoGluon to embed the text category and numerical fields separately, and fuse these features across the modularities. So by using AutoGluon's MM model, AutoMM, we have predict the price of the book here. So we have trained this model. Again, we have used just a few epochs, and we have generated these predictions. Next we have here is AutoMM text, image, and tabular quick start notebook. So AutoMM is a deep learning model zoo of model zoos. So it has many models, and it can automatically build deep learning models that are suitable for multi-model data sets. You can only need to convert the data into multi-model data frame format, and AutoMM can predict the values of one column conditioned on the features of other columns, including the images, text, and tabular data. So for this, again, we have this pet finder data set. And we are using this different features here and identifying the adoption rate and speed here. So this is the model which we have trained using the data set, and these are the scores of the model here. Okay, moving to the next, we have here is AutoMM entity extraction with text and image. So we done this in the text that we have identified the entities in the text like person and the location and all. Now we have here is let's say we have a post on Instagram, or as here in example we have a tweet where it is consist of so it has an image and maybe it can have some caption over it. It can also have some different category of it, different data, a mixture of text, image, and maybe categories, numerical data. So it will extract the entity from such thing. So we have the data set in which we have this example where we have given the text snippet is UEFA Super Cup, Real Madrid versus Manchester United, and we have this data set. We have trained the model on this, and So it's giving this. So this is the model. We are testing it on this tweet, and it is giving this result. So it has categorized these words in this format. We have here is an important part where we are using AutoGluon to forecast in the given the time series. So the tutorial is like in-depth overview of time series forecasting in AutoGluon using AutoGluon. So specifically, we will cover what is probabilistic time series forecasting and what data format is expected, what kind of stuff we are gonna see here. Is like on basis on the previous data, we are predicting what will be the next value, what will be the pattern here next. So here we have taken this, we have installed this packages which is required here, and the data set we have here is like item ID and time series and like timestamp and target. So like the ID and the domain which it belongs to. So I think it is like industry at this time has this value. So let's say this item ID has on these times of it, these were the values. So we're gonna predict what will be the next, what gonna be the next pattern that it will follow. Will it just grow, or will it just it can fall, that kind of stuff. So based on this, we have generated the log target, and we have trained the model on this this new data set, and so now we are doing this, we have imported holidays, and making sure to select just the correct country and region, add one to the year to make sure that the holidays are initiated for forecasting horizon. So this is pretty much it. Like we are using AutoGluon directly to forecast the next pattern. Here it is, this is the output here of the test data, past plus future time series values, and train data. This is like the prediction here. Next over here, we have forecasting with Chronos. So Chronos is a family of pre-trained time series forecasting models. Chronos models are based on on a language model architecture and work by quantizing the time series into buckets, which are treated as tokens. Language models are then trained on these tokens sequence using token sequence using cross entropy laws. So we have this data set here which we have taken, and we are training on a pre-trained data set, and this is the result over here. We can see that this is the output.